So over the next 10 minutes or so, my focus will be around new scaffolds. I'm not going to talk around conventional scaffolds. I'm going to talk about scaffolds that have been, or data has been published this year that I think have very novel concepts and perhaps down the line will change how we think about PCI. So, bioresorbable scaffolds, this is something that has been the dream of interventional cardiologists over the last decade, which after the absorb data perhaps became a nightmare. Nevertheless, there have been metallic platforms that have been developed associated with magnesium. And the beauty of these platforms is that they're metallic, and so we're much more used to dealing with metallic platforms. You know, the expansile properties are much better. And one such platform that has been used and developed by Biotronic over several years has been the MAMAS platform. However, they noticed that late luminal loss was worse than contemporary DES. And one of the problems with MAMAS, the 2G one, was that there was particular problems with scaffold recoil because the degradation of the scaffold was non-homogeneous. Therefore, there's been a new development with the DREAMS 3G platform. Now, the 3G Dreams platform has many advantages. First and foremost, it's thinner. So at 2.5 millimeters, it's less than 100 microns. At 3 and 3.5 millimeters, it's around 117 microns. And at 4 millimeters, it's 147 microns. If you compare that with the older platform, that was 150 microns. Now, this is the really interesting thing. What they've done in this platform is they have replaced the rare elements with aluminium. Now, why is that important? Well, it's important because it makes the degradation much more homogeneous. And you can see from the micro-CT, the top left-hand panel, and the bottom panel just below that, that discontinuation density, i.e. break in struts, was much more homogeneous in the new platform compared to the old platform. So you don't get this problem of acute recoil, particularly at earlier time points. If you look at the right panel, again, you can see much more homogeneous in the new platform compared to the old platform. And this is some of the data, and the important take-home message from this data is that you can see that the MLA between 6 and 12 months was not significantly different. So there's a slight drop initially in the first 6 months, but thereafter it's stable. And again, that's really good data showing that you don't have this late recoil. And this is the real money shot. This is the take-home message from this study. You can see OCT data, and the OCT data at 12 months, so no significant evidence of struts. It's all resolved by 12 months. And the graph underneath, that's the really important one. Compared to the previous generation, late luminal loss is much less. It's about a third less. So I think this is something that is really going to change our practice. And these are target lesion failure rates. You can see it's very low, but this study was underpowered to provide information for clinical safety. That will require bigger trials. In terms of the second platform that I think is really interesting, it's this one, the IBS first-in-man trial. Now, this is an ultra-thin sirolimus-eluting iron bioresorbable scaffold. Now, if you put iron into the body, it will resolve very quickly. However, the beauty about this platform is they put a very thin micro-layer of zinc that stops it resolving in the first 6 months, and then you get a slow degradation thereafter. And that prevents the problems of recoil very early on. And again, the other beauty of this, it's a very thin platform, 70 microns thick. And it has PLA polymer with sirolimus. It's a drug-eluting stent. And this degrades into iron, and iron enters the vessel wall. Particulates enter into hemosiderin, and macrophages clear it up and take it away into the lymphatic system. So I think it's a really novel technology. Now, you may ask, okay, show me the data, and I'll show you the data. So this is data up to 3 years. And the first thing to see is that in terms of luminal late loss, actually, it's pretty good over 3 years. So certainly, you know, that's very promising. You know, a luminal late loss of only 0.2 millimeters is really quite impressive when you compare that to other bioresorbable platforms. Now, this is a slightly complicated figure, but I'll walk you through it. So you can see the red dot, which goes from the bottom left to the bottom right. You can see that's the resorption. So it takes 3 years for the scaffold to completely resorb. And that's really important. Why? It's important because you stop this acute recoil that you often get with other bioresorbable platforms, particularly the ones that dissolve very quickly. The second thing that is quite important is the orange dot. So you can see in the first 6 months there's an acute drop, but thereafter it's pretty stable. So the MLA remains pretty stable. And again, at the bottom, the purple dots or blue dots in terms of neointimal area, it's relatively stable. So you don't have many of the problems that other platforms have. So I think this is a really exciting technology. And again, you can see OCT data that at 3 years it's completely gone. And you can see that target lesion failure rates are very low and MLA is maintained. Nevertheless, this is not showing safety, but I think it's good early data. The only thing that I would say about this platform is that iron particles can create reactive oxygen species, and that can create inflammation in the vessel wall. They don't see that in this small study with OCT, but I think in this sort of technology, we will need much larger studies to look at longer-term safety, looking at clinical events. The final platform is what I think is actually the most interesting platform, the Dynam-X cobalt chromium platform. So that sounds like something out of the X-Men movie. This is actually quite a clever invention. So what this invention involves, it's a cobalt chromium stent, but it has PLLA components that link the rings that are cobalt chromium. And so the thing that dissolves are the links. And so what you get left with are individual hoops that aren't linked. Now you may say, well, okay, what's the point of that? The point of that is that it restores vessel mobility. So that's why I think it's a really clever platform, that you maintain circular rings that are metal, but the links are bioresorbable, and those go. And I'll show you some data, because I think it's a really quite an interesting concept. And this was from the BioAdapter randomized control trial. So this was 445 patients randomized to this Dynam-X BioAdapter with the Resolute Onyx. You know, so it's a good third-generation DES. And the primary endpoint was target lesion failure at 12 months. And this is the data, and this is actually quite interesting. So you could see that for non-inferiority, this new platform is non-inferior, and actually very much a trend towards superiority. And certainly in terms of cardiovascular death, target vessel MI, TLR, definite probable stent thrombosis, it's at least as good as the Onyx platform. Now, this is the interesting bit, the pulsatility. What they've did is measured pulsatility at different parts of the vessel, at the front of the vessel, at the back of the vessel, and in the area where the stent is. And what you see, as soon as you implant it, at the front of the vessel and the back of the vessel, there's lots of pulsatility. In the middle of the vessel, in both type of stents, it disappears. You can see that, the flat line. However, at 12 months, when the links dissolve, you can see that the pulsatility is restored in the Dynam-X, but not in the Resolute Onyx. Now, you may say, well, okay, who cares? I mean, why is pulsatility important? Well, it's important because if you look at blood flow during the cardiac cycle, certainly with this new platform at 12 months, there is much better blood flow. Now, you may say, well, okay, blood flow, you know, why does it make a difference? Well, it makes a difference because in terms of late luminal loss, it's significantly less in this new platform compared to the Resolute Onyx platform. So I think, in conclusion, these are exciting times. They're exciting times because there's a lot of interest, a lot of development in bioresorbable, using iron instead of magnesium, thinking about coating it to make it much more stable. For the magnesium scaffolds, replacing the rare earth elements with aluminium. I think that hybrid approach is very much the way that I would put my money on because it maintains pulsability, and actually the late luminal loss is much less than conventional platforms, but you maintain structural integrity. I think going forwards, we need to move towards adequately powered trial to look particularly for safety with the novel iron stent, but in terms of efficacy, particularly in the longer term for this new hybrid platform. So with that, I thank you, and I'm glad you didn't press the buzzer for me to leave the stage.